what is DevOps basically? Today we'll be having an introduction to DevOps. In order to understand the importance of DevOps, and if you want to confidently face your customers or the clients, so you need to understand the fundamentals first. That's why we call it as a core. So we need to start from the scratch. Before I answer this question, I want to touch base on some important features. If you take any IT service, so predominantly this entire IT services are meant for developing some softwares, right? Software development is the predominant work in any IT industry. Software means an application software, like anything. It can be based upon your web application software, or it can be your desktop application. So here, when it comes to the IT services, ultimately we are going to develop some software, right? The software can be developed for your web-based applications or desktop applications, or even your mobile applications, we can say, right? Apart from that, we have something called embedded applications. So what all these things actually? Any application that you access through your web browser, like if you're using your LMS portal, this is one web application. If you're using your GitHub repository, this is an web application. Similarly, if you're using your online e-commerce portal like Amazon, or if you're using any video streaming portals like Netflix, all these things comes under the web applications. And apart from that, we have something called desktop applications, the applications that you install in one particular machine, in the desktop machine, and handle it. Let's say in my machine, I have installed these many tools, right? So all these applications are considered as the desktop application which I have installed my machine. Ultimately, it is also software. Apart from that, in today's generation, whatever things you are doing through web or desktop, you can able to handle it through mobile itself. That much we are equipped. And apart from all these things, we have something called embedded application, that is something like chip level programming, something like your IoT services. The software, whatever you are using on a desktop machine, will get embedded into the microchips and it will be executed. Chip level programming, like your IoT services, we can say embedded applications. So all these softwares has to be developed by these IT service providers, and how they actually develop the software, what are the process they follow. So in order to perform these activities, there should be some protocol that should be followed at enterprise level. So that's what we call it as a SDLC, that is software development lifecycle. So ultimately, software development lifecycle, it is a set of protocols that denotes or that defines the process to develop any software. So it includes various steps or phases, we can say. As part of SDLC process, let's say, for example, consider I got a requirement to develop a software application. Let's take one use case here. My requirement is to develop a desktop application. It can be for anything, like consider I want to develop a desktop application for one of the supermarket. So in supermarket, we have something called billing systems and all, right? So this is also one of desktop application we can consider. So for this particular software development, we can able to develop, and before we actually develop this software, what we do here is requirement analysis. So requirement analysis means what is the actual requirement? You have to sit with the customer and understand the requirement in detail. That is what requirement analysis means. That is the very first stage in your SDLC process. So once you understand the requirement, you have to properly document it. It can be done through some design, because what are the things you have analyzed here, it has to be properly documented. Then only we can able to effectively develop this software. For example, consider in this particular supermarket billing system, we'll be first identifying the functions. So what are the functions we can have in this software? Like first thing, I need to maintain my inventory, I need to maintain the stock, and then I need to maintain the billing, and definitely the user interface, and something related to your payment module. The payment, it can be a cash module or a card-based payment. So like this, we'll sit with the customer and we'll analyze the actual requirement. What are all the functions we have, time it will take, how many resources we need, and what are the tools you're going to use, where we're going to deploy, whether it is deployed in the customer end or what are the target environment. Everything will be analyzed in detail here. Once the analysis is completed, it has to be properly documented. And once the documentation is done, it will be verified by the customer. We have to provide this documentation to the customer and get a sign off. And once customer approves the design and documentation, then only the product will be developed. That is coding and development. Once coding and development is completed, then we'll be testing the application. And once the testing is done, then we can able to implement to production. And once it is implemented to production, that means the application is live now. It will be given to the customer. Customer will be utilizing this product. And upon implementation, what we do here is we just do some sort of maintenance or monitoring. So these are the various stages of your SDLC process. This is what we actually use in order to develop any software. And to implement this, we have various working models. Like we were using something called waterfall model. So waterfall model means it is one of the traditional SDLC process which includes all these activities. Basically, this waterfall model, it is like a protocol. It is going to use a top-down approach, and it always linear in fashion. It means a sequential process. And another important thing is this waterfall model was meant for your traditional way of application architecture. We call it as a monolith application architecture. I will talk about this monolith application architecture in detail, but as of now, understand it is an architecture that was used in initial days to develop the software. And using waterfall model, we can able to develop any application that is based on monolith. Now, the point is, if you're using the waterfall model, let's say this is my requirement. I want to develop one desktop application and I'm going to use this waterfall model to develop this application. So as part of the requirement analysis in waterfall model, what we do, we will do a detailed assessment or analysis of the requirement and we'll prepare the documentation. Once the document is ready, we can just get it approved from the customer and we'll start with the coding and development and we'll do the testing and finally it will be implemented to production. Now, assume that to develop this particular desktop application, we have estimated like around 12 months. Okay, we have estimated that it requires at least 12 months to complete this whole project. That's what the estimation we are given to the customer, and customer also agree to that estimation to fulfill all these functionalities. So based upon that, we have started the work and currently we are in the coding and development phase. Almost assume that we are in the 7th month of the project. In the 7th month, I think it will be almost in the coding phase. Actually, we'll be doing some coding and doing some parallel testing there. So while you are developing your code in the 7th month of the project, customer wants to add more features to the project. Say, for example, already we have identified 5 functionalities, or I can say like 6 functionalities here, cache and card. Now, customer wants to have one more new feature while you are in progress. Like they want to add new feature, like what they called UPI payment mode. They want to introduce this feature as part of this design. This is what the new requirement. It is not part of the initial analysis. It is not the initial requirement. This is something customer wanted to implement in between. So if you are using a waterfall model, it is not possible to accommodate any new changes in between. Why? Because your waterfall model is strictly follows the top-down approach. Once the design is ready, once it is approved, you have to strictly follow the design and take it to the implementation. In between, you cannot go and change the design or requirement. That is a policy in this waterfall. That's why it is called as a linear in approach. Linear means in sequential manner. Starting from original list till the implementation is go in a sequence. We cannot go back to our previous stage at any point of time. So how we can able to achieve this particular process? Customer have to wait till we complete this project, and we can able to have this as a new project. So it means this can be considered as a core project, and we can have one more project that can be considered as an enhancement. So as part of this enhancement, you can add this feature. Are you getting my point? And this new feature also will be analyzed in detail. It will be estimated, maybe less than that. And then they'll be doing a coding and development and finally implementing it. So this is how the waterfall model works in real-time environment. So the major drawback in waterfall model is whenever the customer wants to make any new changes during the development phase or any phase of your project, it is not possible to accommodate new changes. This was not considered as a drawback. This was the working model initially. Before 50, 70 years back, when the software was developed, right? Like there were a lot of softwares developed during 1960s, 1970s and all. So for a lot of insurance applications, banking applications, trading, stock markets, all those applications were developed 50, 40 years back. By the time this was not an issue, customer can able to accept this process. But now in today's business requirement, if you ask your customer to wait for 12 months to add a new feature, is that acceptable? It's not possible, right? We cannot make any customer to wait for 12 months to add this new feature. So we have to bring in some agility to the process. So if you are still relying on the waterfall model, you cannot run any any business here. For that, they have introduced one new working model called Agile methodologies. So from waterfall model, now we are going to move towards Agile methodology. So this Agile methodology is a software development process. As like your waterfall model, this also follows all the process, starting from the requirement analysis till implementation. It follows everything. But the point is, the approach is different. Here in waterfall model, the entire project is developed as one application. That is what monolith means. The whole application is developed and delivered as one full application product, I can say. The whole software product will be developed and delivered as one full application in monolith architecture. But now, if you're using this monolith architecture, we cannot accommodate new changes. So what we do here is the functions, whatever you call in this waterfall model, let's say if you want to develop the same software using Agile methodology. So what you can do means the functions, whatever we call here, it is also called as a modules. And in waterfall model, Agile model, called as an iterations. Each and every module, each and every function here, we call it as an iteration. And each and every iteration can be independently analyzed, designed, developed, tested, and implemented. So now using Agile methodology, if you want to perform this task, listen carefully. So I'll be creating one iteration. We call it as iteration 1. And this iteration can be meant for my inventory management. And this inventory management function or the module will be analyzed in detail. Correct? That particular module will be function will be analyzed in detail and designed, coded, tested, and implemented to production with proper approval or with manual approval. You see, that is about your iteration 1. Similarly, if you want to work on stock maintenance, you can have one more iteration. This is considered iteration 2. This is for my stock management. Similarly, for second or third module, it will be like a payment. It can be a cash and card payment can be created as a separate one. So like this, each and every function of your application will be developed independently and it can be tested and implemented to production environment with proper approval. In the meantime, if customer wants to introduce any new feature like this, what we can do means we can have this feature available. So I can able to have this nth iteration. This can be meant for your UPI payment functionality. So while you're working on your current requirement, if the customer comes with a new requirement, you can able to quickly create that iteration and start implementing it. Developers can able to parallelly develop that application, design, develop, and implement. So customer no need to wait. We can able to accommodate any number of new requirement from the customer. This is what bringing the agility to the software development process. So now using Agile methodologies, we can able to achieve continuous development. Whenever the customer comes with a requirement, we can able to add one new iteration and develop that particular product. It is possible. We can able to achieve continuous development and we can able to continuously integrate the changes for testing that we call it as continuous integration. And once the code is integrated, we can able to achieve continuous testing there, and also we can able to achieve continuous delivery. We can able to achieve all these through Agile methodologies. But the main drawback in Agile methodologies, we cannot achieve continuous deployment. That is the main drawback in Agile methodology. So what does continuous development means? Whenever we get a new requirement, the development team should be capable to develop it without wasting the developer's productivity. We can able to implement it. Similarly, once changes are ready, we can able to integrate things for further testing, and we can do a continuous testing there through some automation. And continuous delivery means it is a process of delivering a product to the production environment with proper approval. Correct? Let's say continuous delivery means is a process of releasing the deploying or delivering the process of releasing the product, or I can say like changes to production environment with manual approvals. So continuous delivery is a process. It always expect the manual intervention or approvals for production release. That is the reason, if you can see here, at each and every iteration, I use a term implementation to production with manual or proper approval. So that is what the process behind your Agile methodology. Without approval, we cannot move any changes to production environment. That is the process of Agile methodology. But in this generation, let's say I have done my changes, I've analyzed it properly, I've done my changes, and it has been thoroughly tested. Even after testing my application thoroughly, why I need a manual approval, right? If I'm looking for manual approval means, again, it is a time-consuming process, which might lead to some delay in delivering the product. So how we can able to overcome this issue means, instead of continuous delivery, we were looking for an approach called continuous deployment approach. So continuous deployment means it is also a process of releasing changes to production environment without any manual approvals. That's what the point. Never expect any manual intervention or approvals for production releases. So this is a basic difference between your continuous delivery and continuous deployment. Using Agile methodology, we can achieve till continuous delivery, but we cannot achieve continuous deployment. So now, how I can achieve the continuous deployment? For that only, we were introduced to a concept called DevOps. So what is DevOps now? DevOps is also a software development strategy. As like your waterfall model and agile methodologies, DevOps is also a software development strategy or a process. This also follows all the stages of your SDLC, starting from design, code, test. All these activities will be done on DevOps as well. But how it happens, the process that matters here. If you can able to continuously develop the code, if you can able to accommodate new changes at any point of time, why you can't continuously deliver to the production environment? What is stopping there? When I say implementation to production with manual approval, it means all sort of testing should be done there. Without testing, I cannot move anything to prod, right? If I can able to test it properly, why I need this manual approval? Why I can't deploy to prod without any manual intervention? So the reason is the main objective of agile methodology is to bring agility to the process. I don't want my customer to wait for anything. Whenever the new requirement comes in, I should able to continuously develop, at least I should be able to take it up for implementation. So we do a thorough analysis of the requirement, we do a coding, and then we'll do a thorough testing. And before the implementation phase, we expect a manual approvals. Why? Because in agile methodology, people are working for their own task. Let's say this particular module, this iteration is assigned to one developer, means he'll be focusing on his own module. He will not have any clue about what others are doing. Because of his change, will there be any impact on others? He will not have any visibility while he is developing or implementing the changes. For that purpose, once the changes are ready for implementation, we will do a detailed review of all these changes and check if there is any impacts or not. Because of these changes, will it impact others or not? We'll do a thorough analysis and review. And based upon that review and analysis, we'll give an approval for production places. So that is the main thing here. People, they are not interacting with each other during the development phase as well as testing phase. The testing team will not have any clue about what testing they have to do for other module. It is pure depends upon their own iteration. For example, consider I have developed my code here. As a developer, I'm done my coding, and I just move the code for further testing. There is some testing team. I just share the code with them and they are responsible to do a thorough testing of my changes. So today, if I submit my changes for testing, it is completely owned by the testing team now. They'll be taking a complete responsibility to identify the issues, run all sort of test cases and test scenarios, and come up with the test result. Let's say if they are taking around 10 days to complete the testing, means during the time as a developer, I will not have any clue about what they're doing. If their SLA is for 10 days, means 10 days it will be with them. End of the duration, they'll be sending the report stating that these many test cases have been executed, these are things are successful. Till the time, developer will not have any clue about what they're doing. And we are not sure really whether they need 10 days or not. What they actually do, we don't have any clarity on that. So people are working on silos here. That's what the point. They work individually. They will not have any visibility of what others are doing. Because of this, there will be a gatekeeper who will review and approve for production release. Because without proper knowledge, if you simply move to production, it might impact your entire production application. So on that perspective, we'll do a final review and move it. That's the reason why we need this approval process in Agile methodology. So using DevOps, what we're going to do means, first we are going to break that issue. We are going to make the teams to first work together. We are going to collaborate, build some collaboration between the teams. Got it? So ultimately, this DevOps is a software development strategy which helps to promote the collaboration. That is very important thing between the teams. So teams, in a sense, we have something called development team and operations team. When I say operations team, right, apart from development team, who are all involved in the process of SDLC, every team is considered operation team. There is no dedicated team like operations team on DevOps point of view. For any application development, the development team are the core. They are the core assets for any IT industry. They are the business application developers. Apart from development team, you can have your testing team, you can have your infra team, you can have your security team. You can have your production support team. All other teams are actually meant to support this developer team. That's all. So all those guys are considered as an operations teams on DevOps point of view. So using DevOps, first we are going to promote the collaboration between the development team and the operations team. Got it? What is the purpose of creating this collaboration? To achieve continuous development, continuous integration, continuous testing, continuous delivery, continuous deployment, and continuous monitoring. This is the main objective of DevOps. But all these things should be done in more automated fashion. It's not like I have promoted the collaboration, now the team is working together and I have to do all the things manually. It's not like that. Wherever possible, we should automate the process. That's what the objective here. So this is what the proper definition or explanation for DevOps. So if anyone asked you about what does DevOps means, this should be your ideal response. So ultimately, DevOps is a software development strategy that helps to promote the collaboration between the teams, like your development team and operation teams, in order to achieve the continuous development till continuous monitoring in more automated fashion. So now the point is how to implement this. We understood what is DevOps now, right? As a DevOps team, it is our responsibility to implement DevOps. So how to implement? So in order to implement DevOps, let's start from this definition itself. Let's start decoding from here itself. So what I said about DevOps here, it is a software strategy. That is fine. It is a process which helps to promote the collaboration between the teams. So first, your responsibility is to identify the teams who are involved in the process. So all the teams involved in the process of SDLC in any IT industry. So promptly, the very first thing is your infrastructure management team. Infrastructure management team, they are responsible to provision the infrastructure. Provisioning infrastructure means, let's say as a developer, if I want to develop any software, I need one development environment. I need one development machine. I need some development tools to develop it, right? So who's going to provision all this means it is done by the infra team. And this infra team is responsible to prepare the test environments. To test my application, I need some test servers. To deploy, I need some production servers. So starting from the development till production, what are all the servers, what are all the tools needed, everything will be provisioned by this infra team. At any enterprise level, we'll be having this team and you call them like IT support team. Now, the next team is something related to your application development team, AD. They are the core people whose responsibility is to develop the business application. Now, the next thing is we have something called testing team. Once the application team develops the code, it is a responsible testing team to do a thorough testing of it. So what are all things the developer has created, whether he has created as per the requirement or not. The changes, whatever he made, it should fulfill all the business requirements. On that perspective, they do a thorough testing, starting from the functional testing, regression testing, performance testing, everything will be done by the testing team at the core. Once testing is completed, then comes your release management team, who's responsible to ensure that the product, whatever has to be developed and delivered, it is getting delivered on time. Got it? And they are the people who can take a call whether to deliver or not. Due to some reason, if you want to revert the changes also, they can take a call of it. Now, once a product is released to production environment, there is something called production support team, or we call like production monitoring team, right? So their responsibility is to continuously monitor the production environment and support the production related requirements or tickets. And finally, we have something called security team. That is your IT security team. This team is very much essential because they are the people who are going to do some detailed audit. Before anything goes to production environment, it is their responsibility to ensure that the product, whatever developers created, the infrastructure, whatever we created, the tools, whatever we use, it's all done as per the company's security policy. Say, for example, consider I have a Java development team. They want to use JDK. The JDK, whatever they use, whether it is a licensed product or they use something called open source one, it is having any vulnerabilities or any other malwares, everything has to be properly verified. And once they give approval, then only the product will be moved to production environment. In Agile methodology, it is one of the important concern. After thorough testing, just before the production implementation, the security team will come into picture and they will do a detailed security audit. During that audit, they will verify each and everything. Starting from infra team, everything will be subjected to audit. And once they are satisfied with that, they will give an approval for production release. Like this, there are various teams involved in the process of SDLC. Now, where comes the DevOps team? Where can I accommodate this DevOps team here? Okay, so while talking about the teams, I never include any DevOps team here. Why? Because if you implement DevOps, this DevOps team will sit on top of all these teams, because it is our responsibility. If you are part of DevOps team, if you are a DevOps lead or DevOps architect or DevOps consultant, it is your responsibility to interact with all these teams and promote the collaboration. Till that agile process, they might be working on their own phase. They will not have any interaction between the teams. Testing team will be working on their own time frame. They have their own SLA. They don't have any clue about what other application team or other services are working on. But now, as a DevOps team, your primary responsibility, the strategy to promote the collaboration. In order to promote the collaboration, what we do means, as a DevOps team lead or a team member, we have to continuously interact with all these teams and understand their day-to-day activities. And we should be able to understand what they do, how they do the things, and where they are lagging. Consider, I have an infrastructure management team. Their responsibility is to create servers, right? And configure the server. That is their role. How they do this activity? Are they doing it manually, or they do have any automation tools? If I get a requirement to configure around 100 servers, each server will be having its own configuration. How quickly they can able to create 100 servers for my requirement? How much time they consume? On that perspective, we will have to do a detailed analysis, and we will help them to automate their process using some DevOps tools like Ansible, Terraform kind of thing. Similarly, we'll interact with the application team and understand their day-to-day activities, how they develop the code, how they do the automated testing or build. Are they really productive? How we can improve the productivity? On that perspective, we'll do a detailed assessment and we'll help them to improve the process and automate the process. Like this, as a DevOps team, we have to interact with all these teams and help them to automate the process to speed up the delivery. That's it. Because it is ultimately an automation process. So that is the reason. Okay. Even without DevOps team also, these people can work. That is what they're doing for many years. Okay. For many years, these teams were there. Even before DevOps team came into picture, these teams are there in the industry. Dedicated teams are there. They know very well what to do. They very well know about the business. Now, all of a sudden, if you introduce DevOps team, means they should come forward and they should able to provide all the required details, and they should trust you. First of all, please keep one thing in mind. We DevOps team are not here to replace anyone. You are not going to take care of the infra team activity or testing team activity or release team activity. We are not here to replace any team or any resource. We are here to help them to automate the process and speed up their product build and product releases. That's it. So now the point is, this is what the primary role of any DevOps team at enterprise level. Okay, we have a lot of opportunities, a lot of scope in industry now. Now, after identifying the team, the next important thing is you need to identify the environments. Environment plays a very important role to do the automation. Starting from which environment, we have to take the responsibility that matters. So what are the environments we have in SDLC actually? In general, we have something called non-prod environments and production environments. Under non-prod environment, we can have something called dev environment, build environment, your testing environment. And under testing itself, we can have something called QA testing, UAT testing. So upon this QA and UAT level testing, the code will be promoted to the production servers. So this development environment is completely owned by the developers. Where they develop the application code, they'll do some sort of unit testing. And once they're ready with the changes, they will do a build. Build means it is the process of compiling the code and creating the artifacts for further deployments. Once a build is completed, they'll be implementing the applications to further testing. They have to promote the code from build environment, test environment to do the testing. It is quality assurance. And similarly, UAT means user acceptance testing. So now, once the changes are tested thoroughly, it will be promoted to the production servers. This is a workflow, and it depends upon the organization. Sometimes we'll be having some pre-prod environment or staging environment. It depends upon the organization and the release strategy. They can follow that. That's not an issue. So one should understand, as a DevOps team, we need to understand each, because when it comes to infra team, they are responsible to create all these environments basically. So the next thing is, after understanding the environments, we need to another important thing to implement this is your application architecture. So this application architecture plays a very important role in implementing your continuous deployment. So on DevOps perspective, if you consider, we have something called monolith application architecture and microservice-based architecture. We have something called monolith and microservice. Monolith application architecture means it is tightly coupled application architecture. And it means the modules, whatever we have, it's all tightly coupled together. Like initially when SDLC process, like during a waterfall model, if you want to develop a software, the entire software can be created as a single program, one program with all the functionalities. That is how we were developing the softwares in very earlier days. If you see the waterfall model, it is meant for monolith application architecture. Here, the whole software product is developed and delivered as one full application, one component, that's it. So in that particular program itself, we can have a number of functions. So if you write a program with all the functionalities, it is very difficult to enhance it. That's the reason we cannot accommodate new change. Let's say already I have defined 5 functions. Now on top of it, if I want to introduce a new function, means all these functions has to be retested. Because of your new changes, the existing functions should not get impacted. On that perspective, again, we have to start the testing from the scratch. That is the reason we never accommodate any new changes in the waterfall model because of its monolith application architecture. Correct. But if you want to implement DevOps and if you want to achieve continuous deployment, it is required to be a monolith application architecture. So here it is loosely coupled application architecture. It is loosely coupled application architecture. It means every function in the application is considered as a microservice. Every function, each and every function is considered as a microservice here. And it can be independently, service can be independently developed, tested, and implemented. So one important point here is, as part of DevOps, the continuous deployment can be achieved only with the help of microservice-based architecture. If your application architecture is monolith, let's say you are working on some on-premises environment, you have some legacy applications to support, and if you want to implement DevOps for any of your legacy applications that were using monolith application architecture, means you can able to achieve continuous delivery achieved using monolith application architecture. So if you want to implement continuous deployment, it is must to have your application architecture should be a microservice based one. And it's all done by the application owners, the AD team. In that AD team, we have something called application owners, application architects, application leads. They are responsible to prepare this monolith application architecture and consider all the dependencies, and they'll split the entire application into various tiny modules for quicker development and implementation. So when we talk about the microservice application architecture, it is by default, it is loosely coupled. The entire application is divided into various microservices, which can be independently developed, tested, and implemented to production environment. And to achieve continuous deployment, it is must to have microservice architecture. If you are still relying on your traditional approach, let's say in one of my projects, the current project which I'm working, right, it is a hybrid model. We have worked or we have implemented DevOps for one of our hybrid applications where we have our applications running on our on-premises environment, as well as we just migrate some applications to cloud. The basic requirement for our project is to do a cloud adoption, because that legacy applications were running on that on-premises server for almost 30 years. The 30 years old application has to be migrated to cloud platform now. As part of this migration, we were able to migrate all the lightweight applications to cloud platform, but few applications that are tightly coupled, which we cannot break, are still running in the on-premise servers. So if your application is running on both on-premises as well as your cloud platform, and if you want to implement DevOps, means that is more interesting challenge actually. You have to create your DevOps automation to deploy it on your on-premise server as well as your cloud platform. So if the application is still using that monolith architecture, you can able to implement continuous delivery there. With manual approval, you can release to production environment. But the applications that are converted to microservice without any manual approval, I can able to deploy it to the production environment. That makes a difference. We are talking about the DevOps now. What is DevOps? We are clear. And how to implement DevOps. To implement DevOps, we need to consider all these pointers. So the next thing is about DevOps stages. Starting from a continuous development till continuous monitoring. These are things we are going to achieve using DevOps. So that is what we are going to call it as DevOps stages here. This continuous development deliver your deployment monitoring. Okay. So as part of DevOps, you have to be very clear with all these stages. This will be your career. If you're part of DevOps, it means you'll be working on any of this or all of this. You should have any DevOps resource should have clear understanding about all these stages in detail. So that's what we're going to discuss now. So now you should know what is DevOps. It's all about promoting collaboration between the teams and achieving continuous development till continuous monitoring in more automated fashion. So in order to implement this, we need to be clear with the various stages of DevOps. So the very first stage in DevOps is about the continuous development. So ultimately this continuous development means it is the capability of the application team to continuously develop or code the applications. So this continuous development stage, it is mainly used to improve the developers' productivity. That is very important thing to understand. That is a main objective of continuous development in DevOps. If you consider Agile methodology, in Agile methodology also we have continuous development. But how this is different from DevOps means this point is very much important here. Because in Agile also we have the continuous development approach. We take each and every iteration, we allow the developers to continuously develop the changes. That's possible there. But how much it is productive, that matters a lot. So what we are going to recommend to any development team as a DevOps strategy means, first we need to understand the role of any developer. What is the basic role? What is the role of developer actually? Why we recruit developers? Ultimately, we recruit developers to create the application source code. They should be able to understand the application requirement, understand the design documentation, and they should be able to code that application logic. That's it. They are responsible to prepare the application source code for the business. That is their primary activity. But apart from this, developers were involved in many tasks. First thing is they create the source code and they have to perform the manual application build and they have to perform the manual unit level testing. And then once the testing is completed, they have to manually promote the code to test environment like QA environment. And not only that, even after promoting code to test environment, they have to notify the testing team through emails stating that the code is ready. Please pick it up for further testing. Like that, they have to send the notification to the testing team. Then only the testing team will come to know about it. So application build means it is a process of creating the artifacts, compiling the code and create artifacts. So this also developers should do. That is what the expectation in your traditional process, like in Agile methodology. Their primary role is to code the application, but apart from coding, they have to do all these activities. And if developers are involved in all these activities, definitely it will impact their productivity. That is what the DevOps team is going to suggest here. So using DevOps approach, what we're going to do means we expect the developer to create the source code. And once the source code is ready, all that they can do here is they can save or commit the source code to a source code repository. That's it. It can be the Git repositories. So once the changes are updated in the source code repository, from there, DevOps team will take the responsibility. So we can able to automate DevOps strategies and tools. We can able to automate this process. All these processes can be automated. So using this DevOps policies and tools, we can able to automate the application build, unit testing, and then we can able to automate the code promotion and also automate the notification to testing team through emails. So all these things can be done or taken care by DevOps team going forward. That is how we can able to save a considerable amount of time and developers can be effectively engaged in their core business logic development. They no need to spend their effort on all these activities. So this is what continuous development means. It is not just about making the developers to continuously code. It is just how we are going to engage in developers and improving the productivity. When I say application build means the source code, whatever the developer creates, right, it will be in a high level language like Java programming. It is a high level language that has to be converted to the machine level language for the execution. So build means it is a process of compiling the source code and create the artifacts. So artifacts are nothing but the binaries. It can be in the form of WAR file, or it can be form of jar file, or it can be in the form of exec or DLL kind of things. Any executable code that can be deployed in target environment, that is artifacts. Let's say if you want to download any software through internet, what you're doing actually, if you want to install any package, let's say I install all these softwares now. So if I want to install any software, what should I do? First, I have to download the software, right? Yes or no? Through internet, I can able to download the software. While downloading software, whether I am downloading the source code of that software or the executable. So that executable is what the artifacts which can be built and it can be promoted to the target environment. We never promote the source code to any target environment. Let's say I have installed this tool, Eclipse, or I have installed this PowerPoint, means it is a EXEC that was developed in some location and it has been deployed in my machine now. So for this particular tool, my machine is the target server or target environment. So the process of compiling a source code and creating artifacts is what build. That can be automated through your DevOps process. Now, so in order to achieve this, what are all the tools we're going to use? That matters. So if it is a DevOps approach, we always recommend the developers to use some intuitive IDEs. IDE means Eclipse based IDEs. IDEs means like integrated development environments. We never make the developer to use a simple notepad or any other flat file to create the source code. Even in my machine, I have Eclipse to develop the code. I have SQL management. Like that, there are a lot of SDs available in market. Eclipse, PyCharm, and we have something called Visual Studio. The .NET developers, they can use Visual Studio. And we have something called Visual Studio Code. Like this, there are a lot of tools available in market. So we recommend the developers to use these IDEs because these IDEs can be integrated to any DevOps tools in future. It can be integrated to the GitHub repository. They can able to directly commit the changes. They can able to integrate with the testing tools. They can able to integrate with deployment tools. Everything is possible. That's why it is called as an integrated development environment, which can help the developers to quickly do the coding. Next thing is to perform the code commit, they need Git. And to perform the build, they need some build tools like Maven or Gradle, kind of application build tools. Because these are tools that helps to automate or compile the code and create the artifacts. Easy. Now, when we talk about the build tool, it is just to compile a code and create the artifacts. And once the build is completed, it can be promoted to target environment. That is what we're going to talk about the integration, continuous integration. So continuous development means it helps the developers to improve their productivity. And using DevOps, we are going to automate all these things process. So how it is achieved means that is actually done through your continuous integration. So continuous integration means it is the capability of the development team to continuously develop, integrate the changes to test environment for the testing. When I say PyCharm, it is meant for Python development. Your Eclipse is based upon like we have some IntelliJ and all. So all these things are based upon the Eclipse actually. Eclipse is one of the very earlier initial tool that was developed by Java application development process. So based upon that Eclipse only, they have introduced IntelliJ, PyCharm and other stuff. Even your Visual Studio Code also more or less it will be having such interface. The interface will be based upon the Eclipse initially. That's the reason. Now, when it comes to the continuous integration, it is the capability of any application team to continuously integrate their changes for further testing. So it means all these activities can be done through continuous integration. So it means as part of continuous development, the developer's work is this much. That's it. Once the code is available in source code repository, we are going to identify the source code, perform the build, perform the automated unit testing, and then promote the changes to the target environment. So in order to achieve this, we use some tools. Like here also, we can use all these tools. And in addition to that, we'll be using something like your GitHub. And we can use something like Jenkins. If you want to integrate your changes based upon your content images, we can use Docker and Kubernetes. Like this, we have some tools that can be used to integrate change for further testing. Now, once the code is integrated, once it is moved to the test environment, then comes your continuous testing phase. So this continuous testing means it is a process of testing team here. So in order to do this testing, the testing team can use something like your testing tool starting from TestNG, or it can be Selenium. I'm talking on testing perspective, okay? And here also you can use Jenkins to orchestrate those testing process. Everything is possible. So this is about the continuous testing phase. Once the testing is completed, it can be delivered or deployed to production environment. So what I said about deployment, you can take the same explanation here. Following, right? So when I say continuous delivery, it is a process of releasing your changes to production environment with some manual approval. And continuous deploy means it doesn't require any manual approvals. Without any manual approval, we can able to release the product to production release. That's a basic difference here. So in order to achieve this, we use some tools like Jenkins, Docker, Kubernetes, Ansible kind of tools can be used for this purpose. All right. So depends upon the orchestration, depends upon the type of deployment, we can able to use any of these tools for that matter. Ansible is also used for deployment. That's the reason if you see here for our integration also, we can use it. There's no problem. So one should clearly understand the difference between continuous delivery and deployment. So this continuous delivery and deployment plays a very important role. That is what we are going to promptly implement in real-time environment. So you should be very clear about these two things. Let's say, for an example, if you can talk about the continuous deployment, I'll give you one scenario here. You guys are working on using a banking service, right? It can be your online banking, online transactions, whatever you do. It is a software application that is running on their own infrastructure. So as a customer, if you're using this service, you must be receiving some SMS notifications periodically, like once in 3 months or once in 6 months. You must be receiving some SMS notification from that bank stating that due to some maintenance reason, a specific service will be unavailable for certain duration. Based upon your service unavailability, you'll be getting some messages. That will not happen very frequently. Once in 3 months or once in 6 months, you will get such messages. So what exactly happens means they are trying to introduce some new feature or new service, or they want to do some sort of production level implementations. During that time, they don't want any of their customers to access that service. So they will just down that service basically. So that is what we call it as a production release window. It will be hardly for around 4 hours to 6 hours. And we will choose completely a non-business hours. Non-business hours means where the traffic is very less. It can be during the weekends, early morning, where no users can be using that server. They won't do such things during the Monday morning and all. It's a very peak hours. They knew that. So they will choose one deployment window or release window to do that production level implementation. So during that process, they will seek a manual approval from all the stakeholders, starting from the infra team, development team, testing team, release management team, security team. Everyone will be on call. They will provide their sign off. Only then the product will be released to production environment. With proper manual approval, it will be released to production. That is the reason they introduce this downtime. And during this process, if anything goes wrong, let's say they introduce a new feature and it is not working as expected. So what they can do here? So first they will try to fix the issue because they have a 6 hours window, right? Within that 6 hours of time, if they can able to fix the issue, that's well and good. And a worst case scenario, if they're unable to fix this issue, then only they will revert the changes. So who's going to take a call means it is a responsibility of the release manager, the release management team, which I was mentioning here, right? They are responsible to take this call, whether to take it further or revert. So your banking sectors, your insurance, and all, it's all core business. Because of their new features, their existing system should not get impacted. Their customers should not get impacted because each and every minute money matters there. If it creates any issue, it creates a huge mess in the business. So they will never allow the customers to interact with the application during this process. So the 6 hours downtime is a loss of business. It's okay. They are okay with that loss. But whenever they deploy something, it should not create any impact on their production environment. So on that perspective, this will be done. And this is an example for your continuous delivery. In continuous delivery, there are a lot of chances of downtime. So this is how we decide, because banking is a very core application. Okay, like it's all very legacy core applications. It can be running on-premise servers or hybrid cloud platform. So in such situations, we cannot achieve any automated deployments to production. But apart from that, there are some applications, web applications, like you people are aware of Netflix, Facebook, Amazon. So these are all very popular web applications. These guys also doing a lot of deployments every hour, every minute. There'll be some sort of deployments happen on their web application. If you observe it, did you receive any such SMS notification or alerts from these people stating that their service will be down for some reason? No, right? So it means they have a very matured DevOps strategy which can achieve continuous deployment. They are also doing a lot of deployments. If you go to their web portal, amazon.com, if you log in, right, in their portal, you can able to see there are lots, huge applications, huge services will be there. And they can able to independently develop the service, independently test and deploy to the target environment without any intervention and without any downtime. So here, this can be, or I can tag it like production releases can be achieved without any downtime. That is the point. That is, we call it as zero downtime. Without any downtime, I should able to deploy my application service. Whatever I want to deploy, I should be able to deploy it. That is my objective. If you consider the teams, right, even before DevOps came into picture, these teams were there in the field. They very well knew about their application in and out, but still they were unable to know speed up their implementation. So management, the business decided to increase their build cycles, increase their release frequencies and all. So in order to speed up their activity, we have introduced DevOps. So now DevOps team will interact with all these teams and understand their pain points and identify the scope for automation. And through automation, we can able to achieve this without any downtime. We can able to deploy to target environment. So for that, the very first and core requirement is your application architecture. So this is something very much important. This continuous deployment can be achieved only with the help of your microservice application architecture. All these pointers will be helpful to justify these points. So that is how we can able to implement it. Even if you can see here Amazon.com, like if you can see here, this is my Amazon website. So as an end user, what are all the activities I can perform here on this site? As an end user, what are things you can do here? So if you're considering this Amazon.com, just for an example, I'm saying here, as a customer, as an end user, I can perform user login, or I can do something like sign up, and I can do sign in action. Once sign in is successful, I can able to search for a product, right? We can do some window shopping, or we can able to do some add the product to cart, and then we can able to place the order, and we can able to make a payment, and we can able to confirm the order, and we can able to track the order. So all these activities I can able to perform as an end user. But if you consider all these activities on development perspective or on DevOps perspective, each and everything I can consider as a microservice. This is microservice one. Okay, this is microservice one, and this microservice can be independently developed by developer. Assume that I have a developer assigned to this particular service. He can independently code the changes, perform the unit testing, and then they can able to promote the changes. For the testing means, QA and UAT, and then release. So these are all the activities I can able to perform as a developer. Let's say, for example, consider this is my website. On this website, I have something called user sign in as a new customer. This is the default page we have now. Assume that business wants to change the look and feel of this page. They want to change the background color, or they want to add new fields for user account creation. Already we have 4 fields, input fields. They want to add one more field here. This is a new change in that application service. So this change will be assigned to one developer, and he can able to independently, he or she can able to independently code the change, perform the interlevel testing, promote the change for further testing, and they can able to independently develop and release the product to production environment. Similarly, if they have something on sign-in module, that can be considered as service 2, and individually it can be done by the developers. So now, if there is any changes to be done on this microservice, whether it will impact the entire application, to deploy this particular service, do they need to down the entire application? Not necessary, because it is just a smallest task. If you see the application, they have huge list of services. I can see there are thousands and thousands of services here. Each and everything, mouse click, whatever we do here, everything is a service internally. So for each and everything, you can able to see the services here. So all these services can be independently developed, tested, and implemented production environment without any downtime. That is what the main agenda here. For that purpose only, we have something called Docker and Kubernetes in place. Easy. So once you're clear with this, then comes your continuous monitoring. So continuous monitoring, though it is mentioned as a last activity, it is a very essential activity actually. Assume that I have created my microservice application architecture and deployed to production environment. My production application is live now, which is used by thousands and thousands of users. It doesn't mean that I'm done with my work. Okay, after the production implementation only, your actual work starts. For example, consider I have launched this website. Once we launch this website should be accessed by all the customers, right? And it should be available 24/7. So it means it is not just about the application, the infrastructure, that is the production server, which is responsible to run that application, should be available 24/7. If this production server is down, what will happen? We cannot access that application. So there should be a continuous monitoring in order to monitor the infrastructure for the servers, CPU utilization, memory, network, all those things. We have to continuously monitor the CPU utilization and memory utilization of the servers. That is very much important. Why? Because let's say I'm using my local machine. This is my local desktop or laptop here I'm using. If I go to the task manager of this machine, you can see there are a lot of tasks up and running. I can see some front-end applications, back-end application process running. Each and every application and process consumes some resource. You can see overall it is consuming around 20 or on an average it is 40% CPU. And here memory it is around 44% RAM. So if the CPU utilization reaches 100%, what will happen here? I cannot run any process on top of it. I can't even move this mouse cursor because it is also process. So if CPU utilization or memory utilization reaches 100%, we cannot access the server, access the machine. Same thing is applicable for your production servers. So we have to continuously monitor the production servers in order to ensure that the server is available 24/7. So we have some tools here like Prometheus, Grafana, Splunk. Like there's a lot of tools available in market. So we can able to use these tools to monitor the production environment against the CPU, memory, and network utilization. Benefit here is these tools will monitor the infrastructure, and once the utilization reaches 75%, we can get some alert. Before it reaches 100%, we'll get some alert and we can able to respond to the alert and fix the issue. So these alert managers, they can able to, let's say I have this server. If the memory utilization of the server reaches 75%, means that is the threshold limit. And with that limit, I'll be getting an email notification, and it is a response of the production support team to manage those things. If they are unable to manage, they can route the request to the concerned team. And this continuous monitoring is completely owned by production monitoring team. Even as a DevOps team, we will not have any scope here. We can able to help them to automate some process, but we cannot take the ownership of this production monitoring team because it requires 24/7 support. People will be working on shifts like 3 shifts or 4 shifts will be working on, but 24/7 people should be available to support this monitoring activity. Understood? Now, another important thing. So we talked about various stages here, starting from continuous development, continuous integration, testing, delivery, deployments, and monitoring. And apart from that, DevOps is also supportive for your very first team called infrastructure management team. So what is the primary role here? So as part of DevOps stages, we will take care of the infrastructure management team because they are responsible for infrastructure provisioning. Provision means creation, and they are responsible to configure. So when I say infrastructure provisioning and configuration, there are some IT teams, infrastructure management team, they are doing this task for many years, but how they're doing it? Are they doing it manually or they do have some in-house scripts? Because even I have seen most of the people, they write their own shell scripts to automate the process. Let's say, for example, consider I'm part of infra team. To configure and provision the servers, I have written my own scripts because doing it manually is a very tedious process. So I write my own script, shell script to provision the resource, or Python script I write because I'm comfortable in Python or shell scripting. So using the scripting, I can able to effectively manage my resources. Now, at one point of time, if someone takes the responsibility on my absence, that new person also should be expert in the shell scripting, right? Only then he can able to understand my code and he can able to manage the script. So the resource, whoever work on the particular process, they should be expert basically. So all these challenges are there in infrastructure perspective. So to overcome all these things, right, we from DevOps team, we recommend some IAC tools. Like IAC means infrastructure as code. So if you want to provision the resource, we have some tools like Terraform, or we can use something called CloudFormation, or we can use ARM. These tools are used to provision the resource or create the resource. Let's say if I want to create 50 servers, means I can quickly create those 50 servers in parallel. That's possible. Similarly, once the servers are ready, if I want to do some configuration, let's say I have a server created here and I want to install the operating system and I want to, install some required tools and manage the tools, means I can use some IC tools like Ansible kind of tools. These are some tools available market to automate this configuration management. So DevOps supports these two tools. We recommend these kind of tools to the infra team to automate their process. And writing this script using these tools are very easy. It is completely declarative scripts basically using YAML or JSON format. So anyone who wants to create the infrastructure, they can write a script using YAML or JSON format, and they can able to quickly manage the script. It's very easy. It doesn't require, even if you don't have any knowledge on Terraform, just with 2 hours of knowledge transfer, you can able to quickly adapt to that one. That much it is easy. And also, if you want to integrate the Terraform and Ansible, and if you want to automate the infrastructure provisioning and configurations, we can use Argo CD kind of tools. It's possible. Like we talked about Jenkins here, right? Similarly, we can use Argo CD. Even you can use Jenkins for that matter. So Jenkins and Argo CDs are used to automate your process. Jenkins is promptly used for automating your application builds and deployments. Argo CD is something used for automating your server provisioning and configuration. So these are some tools that we can able to use for infrastructure perspective, and DevOps plays a very important role in this area. So how this DevOps is going to provide a solution or take care of this IT security means, so as I said already, DevOps is promptly meant for automating your application builds and deployments, starting from continuous development till continuous monitoring we take care. But initially when DevOps was introduced, right, they were not concerned about the security. Security was a very big concern that was handled at the end. And if you're using DevOps means it is a kind of, drawback we can say. If you see the evolution of this SDLC, initially we start with the waterfall model, right? Then Agile. And then we were talking about DevOps. The next level of DevOps, we can select DevSecOps. So instead of handling the security and its governance at the end, we can integrate this security as part of your DevOps itself. So it means security will be part at each and every level now if you implement DevOps. So as part of continuous development, developers will be aware of the security policies and the concerns, whatever they should follow. I'll give you one small example. Consider I am a developer. I have created a source code and the code has been committed to source code repository. Upon proper testing, we have automated the code promotion. And now using this continuous delivery approach, we are trying to deploy to the production environment. I'm not talking continuous deployment. It is a continuous delivery approach. During this continuous delivery, there is some sort of manual approval is required. Now your security team will come into picture. These guys will come and do a complete audit of your application source code. What are the things developer created? They have to verify the source code. They will scan the entire code and check for the coding standards. They will check whether the code has been developed as per the company's coding policies or not. They'll check whether the code is having any vulnerabilities or threats. If they identify anything, they won't allow to implement the production environment. Got it? So upon thorough testing, just before the production release, the security team will come into picture and they will scan the entire code. If the code is valid, then only it will be promoted to the target environment. Otherwise, they won't allow the production release. So it is a kind of last minute surprise. Through DevOps, we put a lot of effort and we were able to move it to the target environment. But just before the production release, there is some security concern. So because of that, we have to start rework. Developer have to remove all those vulnerabilities and they have to start from scratch. So to overcome this issue, what we're going to do here is through DevOps strategy, we are going to bring in the security as part of development activity itself. Developers, while they do the coding, by the time itself, we will recommend developers to follow the security policy. We will involve the security team here and we will get the security policies and other stuff and help the developers to code the changes as per the company's security standard. So once they start the coding as per the company standard, obviously the code will be secured. It will be as per the quality, code quality. It won't create any last minute surprises. That is the reason we were introduced to DevSecOps. And as part of this IT security, we use some sort of static code analyzer like SonarQube. We can able to set up a SonarQube server or Sonar Cloud. We can able to use it for validating your changes. There are a lot of tools available. Like it is not just about a static code analyzer. We have something called dynamic code analyzer also. Like we can use something like HP 45 check marks. Like there's a lot of tools available in market to ensure the coding standard and the things. So it's all depends. Okay, depends upon the company's coding standard. We can able to implement one by one. So that is about your DevSecOps. And in real-time environment, just before the code integration, as part of the development phase itself, we will implement the code quality check. Developers, once a code is ready, while doing the coding itself, this ID can be integrated with the SonarQube server using some SonarLint. SonarLint is another tool that can be integrated in Sonar Eclipse IDE, which can be connected to SonarQube server, and we can able to validate the code there itself. Now, developers, before they integrate the code for the next environment, in the very initial stage itself, we can able to identify all the security related issues. So this is what we actually call it as shift left approach. Okay, that is what for vulnerability. That's what I'm saying, right? The Sona Kubernetes is meant for vulnerability check only. Ensure code quality and zero vulnerabilities in the code. So using these tools, we can able to verify it. What does shift left approach means? Consider I have a dev environment, and from dev environment, I move to QA, and here from QA, I can able to move to UAT, and from there, I can able to move it to production. That means the changes will be traversing from left to right. So the process, the main objective of DevOps and DevSecOps is what are all the issues, what are all the vulnerabilities that might occur in the program should be identified at the very earliest stage. We should shift one step down and identify the issue. The issue should not be identified in the QA environment. It should not be identified in the UAT or in the production environment. It should be identified at the very earliest stage. Using shift left approach, our intention is to identify all the possible code vulnerabilities and the code related issues at the very earliest stage. That's the reason we implement this in our DevOps workflow. So that is the main objective of your DevSecOps here. It's a kind of evolution, actually. We can say software development strategy, right? Evolution of SDLC. And not only that DevOps, okay, we have a lot of things. We have something called AI Ops. And even before AI Ops, I can say like GitOps. We have something called MLOps. So it is not about just build and deployment. We have a lot many things in place. We have lots of opportunities to work. All these things will be comes under the DevOps engineering scope. We are responsible to implement it one by one. So as part of this, you need to be very clear about the DevOps lifecycle. So the lifecycle DevOps, it's all starts from the developer. Create the source code, application build, we'll do a testing, and we'll just deploy to prod. And once it is deployed to prod, we will monitor, and this monitoring will be giving some feedback. So that feedback will be again sent to the development team. So development team will work on that changes. Again, they will perform build, test, deploy, and monitor. So like that, DevOps will flow in an infinite loop, starting from the development till monitoring. It is a continuous process. So we implement DevOps. Okay, DevOps is all about continuous improvement. We talked about continuous development till continuous monitoring, but the main objective is to achieve continuous improvement. Every day there should be some sort of process improvement we should experience. We cannot achieve all these things on the same day. It is a continuous process. That's the reason we have various levels here, starting from DevOps, DevSecOps, GitOps. We can able to implement one by one. So people who are working on DevOps, we have very good market, and we have a huge demand for DevOps resource. Means we have lots of opportunities to work on this area. Let's say today you implement DevOps for one customer. Assume that you took around 2 years to implement DevOps for that customer. It doesn't mean that you're done with your work. You can recommend the customer and move towards DevSecOps. And once DevSecOps is implemented, we can able to implement GitOps, AIOps. Like that, it is a process change, right? Towards the continuous improvement, we have to take it further. So for any DevOps resource, you should have a continuous learning ability. Don't just stop at once. If you learned about Docker and Kubernetes, that is not the end. You have to continuously learn the things. You have to adapt to the new tools and technologies so that you can able to retain in this field. So ultimately DevOps, right, it is based on 3 important entities. One we call it as people, the process, and the tool. So people are the very first and foremost important entity here. If you want to implement DevOps, people are the very first key for implementation. That is the reason as part of implementation, I have identified teams here. If you remember how to implement DevOps means first I have identified the teams, because these are the people who are actually going to support the implementation. If you're not getting any support from these people as a DevOps team, you cannot achieve anything here. So based upon the discussions with the team, based upon their inputs, we define the DevOps process and DevOps strategies. And once the process strategy is defined, the tools are nothing but it's just a package, right? We never give importance to tools in DevOps at any point of time. Tools are, after all, just a tool. That's all. We always give importance to the process, actually. Why? Because consider today, I want to implement my automated builds and deployments using Jenkins. Assume that I've decided to use Jenkins. What if down the line, after 5 years, Jenkins is not there in market? or you're using Terraform today. What if Terraform is not there in market? It should not stop your process, right? So the process, whatever you define, it should not be related to any specific tool. It should not depend on any specific tool. It should be a generic solution that should be implemented for your continuous improvement. Any tool that comes into market, your process should able to adapt to the tool. That is what we call it as a successful DevOps implementation. If you blindly define some process and implement means, then once in 6 months, you have to change the process. Okay, it's a very tedious process then. You cannot achieve continuous deployment there. If you cannot achieve continuous deployment, there is no point in using DevSecOps, AIOps, and MLOps and all. There is no use. So if you want to implement DevOps, you should consider continuous deployment as a matured level of DevOps. And it is not that easy to achieve continuous deployment, okay? It is not that easy. Your Amazon.com or Netflix or Facebook, they were able to successfully deploy their services without any manual approval and without any downtime means. Just assume how much they have strengthened their process. If the process is not strengthened, they cannot achieve this. And without their people, without their team support, they cannot strengthen the process. Everyone should rely on this, should follow the process. Then only it is possible. So this is all about your introduction to DevOps. So next, we'll be talking about your version control system using Git or GitHub.